Welcome to the next section of Nanoindenter training. In this section, we're going to cover how to set up an experiment. Before we do that, though, I want to show you one option in this Options button. In this window, under the Find Surface tab, there is a number. It's called Z above surface. And this is when the system finds the surface for you, it's going to pull the tip off the surface a certain distance, and that's what this number is. 5 is a good number to start with. If your sample really is sticky, you may need to use something larger, maybe 10. If your sample is not sticky at all and you want to speed things up, you can make this a little bit smaller, maybe 1, 2, 3 microns. For now, I'm going to leave it at 5 and save that. And then come into this Configure Experiment button. Now, there are a couple different types of experiments we can do, a single indent and a matrix scan. I'm going to start by showing you a single indent. And so we're going to come to my training programs folder, and I'm going to call this single indent 2. So once I have my file name at the top, I need to add some steps to this program. And so I'm just going to click this Add button. It's going to add a step, but the step doesn't know what to do yet. So over here, I have to select a function for it to perform. And I'll admit the only 2 functions I've used are indentation and matrix scan. Let's start with indentation. In the general section, it's asking me where it's going to save that data. And so I'm going to come back to this PC, C drive, data, my folder, and I'm putting all my training data in here. I usually create 2 folders in the folder that I'm going to save my data, one for all the single indents and one for the matrix indents. So I'm going to put it in the single indent folder. And we're going to call this is my file name now, training sample 2. And we're going to do indent control. I'll explain what that means in just a minute. So now that I have the path to save the experiment and the path to save my data, I can start to create the actual profile. So there are 3 things I can control when I'm doing an experiment. The first is displacement control. Let's talk about that one first because it is the simplest. In this experiment, the instrument is only controlling the Z piezo, which is what moves the entire tip up and down. And so, for example, I had told the tip to pull off the surface 5 microns after it found the surface. So I might write a program that looks something like this, where it's going to start at a starting point of 0 in my Z displacement. It's then going to go 6 microns in 2 seconds. It's going to hold there for 0.1 seconds, and then it's going to come back off the surface, retract that same 6 microns in, again, 2 seconds. That program is detailed over here on the right, and I can make changes to any of that. Maybe I want to go 7 microns. And there's my new program. The number of steps is indicated up here, so I can always add another step or delete a step if needed. Now, this type of experiment, the displacement control, is the simplest experiment. There is absolutely no feedback in the experiment. It just moves down 7 microns, moves back up 7 microns. This kind of experiment sometimes makes me a little bit nervous because what if I'm usually hitting something really soft, but that soft coating is not covering my entire substrate. So what if I hit that really hard sample and I try to, indent 2 microns into a really hard sample? I may do some damage to my tip. So the 2 other options that I have, load control and indent control, use some type of feedback. Let's talk about indent control first. In this experiment, the tip is going to approach the sample at some approach speed. Here it's set at 2 microns per second. It's going to make contact and detect that contact. The contact threshold is how sensitive it is to making contact. So I believe lower numbers here are going to make it more sensitive to that contact point. Once it makes contact, then it follows the program that's written here. And so in this case, I'm asking for a 500 nanometer indent over the course of 1 second. I hold there for 0.1 seconds, and then I come back off the surface again at the same rate, half a micron per second. Again, I can control the number of segments if I need to over here. So in this case, the system has to detect contact before it is going to run this program. And what I've noticed is that it very often does not detect contact where I think it should have detected contact. And so I often make this indent smaller than what I want, because I have observed that it typically overshoots this. The other type of experiment we can do is a load control experiment. In this case, it approaches at a certain speed, just like it did before. When it detects contact, it is now going to have a feedback loop based on the force. And so in this case, I'm asking for a force of 0.01 micronewtons over 2 seconds, a hold of 0.1 seconds in the middle, and then pulling back off the surface at that same rate. Again, this relies on feedback and it being able to control this in real time. If I'm going to do a load control experiment, a lot of times these numbers I don't know off the top of my head. And so I will often do a displacement control or an indent control experiment first, figure out how much I want to indent and what load that corresponds to, and then go from there. But the experiment I want to do right now is an indent control experiment. So I'm going to keep this here and I'm going to save. And I think it is going to make me save this one more time. A lot of times the first time you write a program, it likes to make you save it twice. Okay, so I think we've got that saved. The other type of experiment we can do is a matrix experiment. Now, this is similar, but we are now taking data in a grid. And I'm just going to load this program that I wrote before. Again, it has one component to it, and it's just this matrix scan. I can always change that if needed. Again, this is sample, training sample. We're going to call it training sample 2. And again, we're going to use indent control. And it looks like it's already set up to save in my matrix indent folder. So that's great. I don't have to come over here to change that. The profile window looks exactly the same as what we just looked at. So I'm not going to go over that again. But the matrix scan window is new. So in this window, I can control the number of points I want in my grid. Maybe in this case, I just want to do a 4x4 micron grid. And maybe I want the steps between my points to be actually a millimeter. Our stage can travel 12 millimeters by 12 millimeters. So this is something that is certainly doable. These numbers down here are where it's going to start that matrix. And sometimes it is not, these are not your current positions. So I typically will just hit this button here, and it looks like they actually were, but this allows it to import your current XY positions into the program, so it starts exactly where you are right now. There are two other numbers to look at. Z at XY move is the height that it's going to move the tip to above your surface before it starts moving in X and Y. Now, I like to be nice and far away from the surface when I do this, because a lot of times I have samples that I don't know a lot about, and I don't know what their height variation may be. And I don't want the tip to crash into a rough surface. So I typically use 300 microns above the surface. This number over here is similar to what I just explained earlier. When it's doing this matrix scan, it's going to find the surface, pull the tip off the surface, and then do its indent. And this is the amount it's going to pull off the surface. I'm going to leave it at 5 for right now. The profile that I had set up earlier is the one that I want to use. So this looks good. Let's go ahead and save it. Yes, I'm going to replace the existing experiment. So that is how you set up experiments. In the next video, we're going to start taking some data.